Welcome to Study Loop.
Hi everyone, here it is given. A refrigerator operating on ideal vapor compression. A refrigerator operating on ideal vapor compression refrigeration cycle with a refrigerant 134a as the working substance. We have to find the increase in coefficient of performance. Increase in coefficient of performance if throttling process were replaced by asentropic expansion. Let us see here assumptions required to solve the problem. First one is steady operating condition. Second, kinetic and potential energy. Changes are negligible. Let us see here the analysis. In an ideal vapor compression refrigeration cycle, the compression process is isentropic the refrigerant enters the compressor as saturated liquid, sorry, as saturated vapor and leaves the condenser as saturated liquid, saturated liquid at the condenser pressure from refrigerant table temperature T1 is 20 degree Fahrenheit. Fluid state is saturated vapor. Heat capacity is at the rate of 20 degree Fahrenheit 106.00 BATU per pound mass. Entropy at, at the rate of 20 degree Fahrenheit 0.22345 BATU per pound mass river P2 300 psia S2 is equal to S1 and heat capacity is 125.70 BATU per pound mass. P3 is 300 psi. Fluid is saturated liquid. Heat capacity or thermal capacity is 300 psi, 66.347 BATU per pound mass, and entropy S3 is equal to SF at the rate of 300 psia 0.12717 BATU pound mass per river. H4 to be equal to S3 66.347 BATU per pound mass. That is the process of throttling. T4 is equal to 20 degree Fahrenheit. S4 is equal to S3. H4x 59.81 BATU per pound mass, and liquid state is 0.4724. Liquid quality process is isentropic expansion. The coefficient of refrigerator for throttling case COP for throttling case QL upon power in, that is H1 minus H4 upon H2 minus H1 106.0 106.0 minus 59.81 upon 125.7 minus 106.0, that is 2.344, and increase in coefficient of performance by isentropic expansion. 2.344 minus 3.013 upon 2.013, that is 0.165 or 16.5%. That's all. Thanks for watching it.